Alrighty, test, test. Test, test. Almost. Oh dear. Nothing can be perfect, can it? Where are you? That doesn't want to work, does it? Great. Okay, we can work around this. Alright, for now, let's go with that. Okay. Test. Is the audio okay? Is it alright? Does it work? Is this working? Yes, this is working. Yeah, it doesn't look like the capture for the problems is working right now, so let me see if I can fix that real quick. If you are in the chat, say hi, so I know who's here. Why is this not working? It was working 30 seconds ago before I went live, so of course it can't work now that we are live. Why would it do that? All right, come on. Come on now. Oh, I don't want to Oh, come on. Really? What if I do... Oh! Have I done it? I've done it. Haha! I fixed it, somehow. I just checked the box and it went on. I don't even know which box I checked. Is the audio too loud, by the way? I don't know. I had it at max gain earlier, so it might be too loud. How's it going? There is some stream delay, so apologies if I don't see your comment till a little bit later. Whew, it has been a while, hasn't it? Some of you have been to past streams, so you would know. But yeah, it's been a while. I've got some stories to tell. Figured I might as well go for it before we get started. I'm going to try to do this stream rather quickly because I have somewhere to be at 5 and I'm going out of town after that. So hopefully I don't skimp on the content, but if I have to jet, then I will. But I think we'll have plenty of time. We got like almost 2 hours to do it, and usually these streams take an hour to an hour and a half-ish. So yeah, we'll see. How's everybody's week been? It's Friday. It's Friday. Friday's awesome, right? Looks like we have 4 concurrent viewers. That's just fine. The 4 of you that are always in chat, just know you have my undying appreciation. Because it means a lot, really. I mean, I know that sounds a little sarcastic, like I don't mean it, but it's true. Hold on, I'm gonna move the camera just a little bit. Hopefully everything doesn't break. Because I feel like it's off center. Better? Better, yeah. Also, the tripod just died, so I think if I touch it, it's just gonna wildly swing. So let's not mess with that. Any word on the audio before I start talking at length? Got a motorcycle outside. Dude, the water is like a staple of my streams at this point, but my fridge just kind of randomly started being too cold. And I know it's like a brand new fridge, so I don't think it's broken. And I know there's a temperature setting inside, but I didn't mess with it. And now it's like too cold. So is that like a thing that happens? Does anyone know about that? I'm like new to living on my own, so I'm like going through first time renter problems. Audio's okay? That's good. Yeah, so I don't know if any of you guys saw not the example video that went up last night, but the one that went up before that. But I was doing the audio, for said example video, and I heard basically schizophrenic whispers over the mic. And I couldn't figure out what it was because I remembered during the streams somebody had mentioned that they heard voices in the background. So I did extensive testing of the audio and I turned the gain all the way up on my microphone to isolate the sound. And I found out I was getting radio interference through my house because it's an old house. So yeah, basically you will, if you listen extremely closely, it's possible you'll be able to hear the local radio. Apparently. That's a thing. Who knew? Problems you didn't even think were physically possible, but here we are. Here we are. Yeah, no, I've not been streaming. I've had a lot of stuff happen in the last couple weeks. The audio issues, my car broke down, had a funeral to go to, all kinds of weird stuff, man. It's been a trip these last couple weeks, believe me. But we're back. We're back, hopefully to stay on schedule. I know we're not like truly on schedule because I was doing the first half of the problems on Monday and the second half on Friday, but I guess we'll just be flipping it on its head and finishing the week's problems on Monday now, just to stay on schedule. Hopefully I can stay on schedule. It's quite difficult, to be honest. I mean, these problems are not easy, and I have a lot of other stuff I do for the channels and stuff, plus, personal life, but anyway, looks like we're getting some viewership now. Is it it's story time? Story time brings in the viewers? I don't know. Alrighty. Yeah. So, yeah, we're going to be doing these first 11. Let's kind of like look at them real quick. I can scroll through them so you can see the ones we're doing. We got this limit point 1, 3x3 matrices, invertible matrices, quadrilateral, logic table 1. Oh, that's just the answer choice there. Got this one. This one was fun. This like block of text here. Surprisingly hard to approach and surprisingly easy to solve, like the best kind of problem. Got a cool product here. I don't actually remember how this one happened, how like this one got solved, so. Yeah, we're not doing this one. I don't even know how to approach this one. So just, if for those of you who are watching this in the post when it goes up, you can tell me how you would have done it. And for those of you on stream, if you are like, whoa, that's easy, you can do it and post in the stream chat and see if everybody agrees with you. We got this, and then we got 2 integrals to finish off. So not too bad overall, I would say, for this week's problems. Keep in mind, I did these and wrote my notes for them like the 2 weeks ago, like on time basically. So I don't even remember these. So it's possible I'm going to fumble the bag here. But it's all right. It's all right. It's better to stream than not, right? Also, alerts are off for today's stream, as I couldn't like launch the alert thing because I lost the login to the channel and I need to get it again. So no alerts. If you subscribe or super chat $5 billion, please tell me in the chat so I can thank you personally. I think I can check it through like the normal YouTube stream thing though. Maybe? Let me check. I feel like, is this it? Yeah, I can check. If you send me copious amounts of money, I can check. I think you guys can super chat, but we don't have channel memberships yet. We might want to launch that soon. That would be hype, right? Launching channel memberships. I don't know. I feel like I'm talking to myself. I got no chat. But there's people here. But yeah, channel memberships would be cool. I don't know what we would do with it, to be honest. I mean, really, it's like anything else. You get like some emotes and a badge. That's the streaming classic, right? You get a funny little thing next to your name, and that's it. You get to pay money for that. But I think it would be cool. I mean, obviously, it's like however you want to support the channel. Hello. It's good to have you guys here. I think I'm going to get started here in maybe just a minute. Yeah, I'm going to probably go from my notes, and then we'll just kind of feel it out. Looking forward to see some feedback from you guys. How was everybody's week? Talk to me. You guys have a good week? I had a busy week. Yeah. Car breaking down, not good. Had to get it towed. It like when it broke down, I was just driving down the road and it just like turned off. So that was stressful. So I had to like, get the car off the road safely, obviously, and then call a bunch of people and then insurance, and then you get it towed, and then had to go over there and get all this stuff and get it fixed. So that was basically like a lot of the week was dealing with that along with the normal stuff. But yeah, my week, I wouldn't say it was great overall. But by the weekend, by Friday, it's shaped up to be pretty good. I'm going to go out of town this weekend, so that'll be fun. My birthday week's next week. My birthday's actually on Wednesday, so, I doubt anybody will remember, but there you go, Not that it really matters, but... Okay, let's get into some problems. Alrighty. So, see if I can, work this, it's been so long. Boom, magic. Okay. So I'm going to write this is number 1. I'm going to know which points. Oh, your phone broke down. That's terrible. What happened to your phone? Did you drop it or something? Which points x and y on R2 are limit points of the set big X is equal to A and B in R2 such that B is equal to A inverse secant of A inverse. Okay, so let's graph this thing to kind of see what its behavior is. Nope, that's not what I wanted. Hold on. Bringing up my notes. You can't see them, but I can. Is this it? No. It's definitely one of these, you know, it's definitely one of these. Oh, what did I do there? Okay. I thought I had this up already, but no, I gotta stall a stream. Okay. So let's draw the curve. Y equals, or well, rather the curve that we're looking at is y equals the secant of 1 over x, which is a function of x. So let's draw, like, should we use colors? What colors are we feeling? I'm feeling blue. Let's draw our, our graph here. Look at the behavior. I mean, I know what it looks like, but you don't. So this is, I'm going to be drawing the secant of 1 over x, because like this is really just going to be like a limiting factor. We can't have x equal to 0. So secant of 1 over x is like this, vaguely. Something like that, right? Let me make sure I'm not blocking the screen. Stopped working, but you're having it repaired this weekend. Oh yeah, dude, screen repair is not cheap. I'm actually getting a new phone today, believe it or not. It's kind of a coincidence, but yeah, screen repair is not cheap. It's like, I mean, in my experience, it's like $100 or something like that. It depends on your phone though. If you get like a newer, fancier phone, obviously it's more expensive. Okay. So let's go ahead and look at our answer choices real quick. Boom. There we go. Can you see all the answer choices? Yes. Okay, so we have the set has no limit points. The points y equals x inverse secant of x inverse, where this is defined, along with the points 0y with y greater than or equal to 1. 0y. Okay. Only the points y equals x inverse secant of x inverse, where this is defined. Only the points 0y, only the point 0y with the absolute value of y greater than or equal to 1. It's not the absolute value, is it? That doesn't even make any sense if that's absolute value. I guess that means not 0. Yeah, okay, yeah. Okay. So let's get the definition of a limit point. How about that? That seems like it would be important, right? Let me get back to here. So I'll write down the definition of a limit point. Alrighty. Limit point definition. We want the topological definition, right? Okay, so the limit point definition is that for some p in x, or p is a limit point of x if and only if every neighborhood of p intersects x. How do you abbreviate neighborhood? And yeah, like this? Sure, why not? Neighborhood of P intersects X. Okay. Every neighborhood of P intersects X. Okay, so like we can, so by that definition we can tell that like the points, oops, the points on the curve are obviously going to be limit points. So it has limit points, because any point on the curve, you can't draw a neighborhood around a point on the curve and not intersect some other point on the curve. That's because it is continuous throughout both of these things, and there's no value at 0, obviously. So by that, so if it's continuous on the domain, we know. So yeah, can I finish this? Let me check and make sure I'm not going to run out of room here. Oh, there's a bot. I have to kill the bot. My apologies. Bot destroyed. Bot obliterated. Okay, so what was I going to say? Okay, yeah, I think I can fit this in here. Okay, so we have f is continuous. Let me just like write down what I was saying. I really need to turn that feature off. I asked on like the first stream how to turn that off, and somebody told me, I just haven't done it yet. So if f is continuous on the domain D, then here, I'm going to write it over here so I know it's good. Then g of f, this is the graph, is just what you would think a graph is defined as. I'm just writing this for my notes for the record, in case you're wondering why I'm like not explaining it while I'm writing it. Yeah, I mean, that's the definition of graph. But the most important thing to take away here is that the g of f is closed. And closed means it contains all its limit points. So that means we have all the points on the curve there, which is basically what I was just saying from observation. But we know that there's no limit point at 0 because we can take a really small neighborhood and dodge the curve pretty much anywhere. You can just take a smaller and smaller and smaller neighborhood. So that means the answer choices with 0 don't work, which gives us, that just narrows it down, because it's 0, 0. Like 3 of the answer choices have 0, and one of them's no limit point. So the answer is C. So only the points y equals x inverse times secant of x inverse where it's defined, that's our limit points. So C. All right, cool. Good. All right. So let's go to the next page and look at the next problem. 50 of 50. I have 50 pages in this notepad. I think it's because I just copy over like the last notepad and don't erase it, because I'm being lazy. I'm going to fill up the water. You're going to see my ice water. The fridge lore. Just hit the lamp. The next one I think is pretty easy if I remember correctly, but I don't actually know if I remember the logic of it, so we'll see if we can kind of like uncover that as we go. Okay, so let me put the problem on the screen. So we have, let A be a 3 by 3 real matrix with 0 trace, and such that the trace of A squared is 1. If A is not invertible, then what's the largest eigenvalue of A? Okay. Let me get my notes on this one. Okay, so let's just write down what we know. So we know that by definition, A is in the set of 3 by 3 matrices on R. And we know that the trace of A is 0, and that the trace of A squared is 1. So, oh, we know it's not invertible. That's also important. A not invertible. Okay. Let me see. What's the definition of trace? I don't have a super strong abstract algebra background. Trace definition math. A trace is property of a matrix and linear operator. Yeah, that's not helpful at all. Yeah, let's go to Wikipedia. The trace of a matrix is defined to be the sum of elements on the diagonal. Okay. On the main diagonal. So the trace of 0 means on the main diagonal we have... Oh, okay. Yeah, that makes sense. It's only defined on the square matrix. It can be proved that the trace of the matrix is the sum of its complex eigenvalues. So this only matters for diagonalizable matrices because it's on the diagonal. Yes. Am I correct in saying that? Okay, hell, let's go to the iPad because I just wrote all this and you didn't see it. Boom. Not that that's super important. Non-invertible. Okay. So if we're talking about diagonalizable matrices, we will have... So because it's the sum, it's a 3x3 matrix and the sum has to be... the sum of the trace has to be 0. A will be like similar to 0, 0, 0, 0, lambda 0, 0, 0, negative lambda, because the trace has to be 0. And let's see, for a squared, what is the source of these problems? Yeah, let me give you a link. We are using the University of Chicago 2019 GRE Prep, and we are on week 4, and we're doing the first 11 problems. So let me drop this in chat for you real quick. I gotta go to the YouTube because I'm not logged in on here. That is the source of the problems for you. All right. So we have A similar to that for the trace to be 0, right? No objections there. And that means that means A squared is going to be something like this. Well, not something like this. It's going to be, I guess it is something like this. It's going to be zeros, lambda squared, and lambda squared. And we know that that equals 1. Yeah, no problem. So we can make a system here. Yeah, now we just have an equation. So we have 2 lambda squared, that's from the trace, is equal to 1, which means that lambda is equal to plus or minus 1 over the square root of 2. Is that just the answer? Wait, no, it can't be minus, can it? Oh, it's the largest. It's asking for the largest eigenvalue. So yeah, it's plus this. So largest is plus 1 over the square root of 2, which isn't an answer choice, but 2 over the square root of 2 is, and that's just rationalizing this. So the answer is B. Square root of 2 over 2. If you multiply by root 2 on both, you'll get square root of 2 over 2. All right, so far so good, team. Looking good. Looking like I remember these problems better than I thought. I mean, I have notes to help, but, Oh my gosh. Bots. Dude, where do these chat bots come from? There we go. Where do they come from? Do not return. Banished. Okay. So let me get the third problem up here. This one is... Oh, this one's fun, I feel like. How many invertible 3x3 matrices are there with entries in F2? All right. Let me bring up my notes on this one. The notes just keep me honest. I do these on a chalkboard because I don't know if you guys experience this. I mean, you probably don't have like access to a chalkboard like in your house or whatever, but when I was in school, I would stay in the academic buildings until like midnight because when I would work out these really hard problems, the chalkboard just felt like the best place to do it. If you're working on paper, you have to erase a million times, and I feel like if you're writing on like an iPad like this, you get like really cluttered and it's not helpful. I feel like the chalkboard's like the best place. Or a whiteboard is the equivalent. It doesn't really matter, I don't think. Probably made some people mad that care about whiteboards and chalkboards a lot. But I feel like it's just a workspace. Okay, So we want to know how many invertible 3x3 with entries in F2. I think that's how you write F2. So we want to know the order of GL3 in F2. So we have like a 3x3 matrix. This is taking me a while to draw. Could have copied it. Okay, so what is our limit? It has to be invertible. That's our limiter here. So the first one can't be all zeros, but I think, yeah, dude, I'm sorry. It's interference. So like I said, my house is near a radio tower. So, which I, of course, didn't know till I heard the radio. But there's really nothing I can do about it. I talked to my landlady, and she said she's going to, like, ground this outlet at my desk. But until then, with the exception of maybe running, like, a really long extension cord from a grounded outlet, which I currently don't have the means to do, I don't really have any way to avoid that other than by talking a lot and hoping I block it out. So if you hear that, you have my apologies. Like I said, I'm working on a solution, but it's not going to be, like, super fast. But I may just try and get a power strip and just, like, run some crazy cords for when I stream. Because when I record, I can, like, just sit somewhere else. But I can only stream from my desk because, like, there's nowhere else I can sit in my house that works. Anyway, so we have two choices for each of these. So we have 2 cubed, just from probability, minus 1. So we have 7 choices here. And then I think for this one, we can have anything except for linear combination of the first row. So that gives us what? 3. What does that give us? Well, it gives us 2 cubed minus. You could have two possible linear combinations, right? I think it's 6. And then for the last one, no, it's not linear combinations. It's multiples. You can have 2 multiple. That's why that makes sense. So like this is 0 zeros. This is multiple of row 1. They can't be the same, basically. And then for this last one, that's the linear combinations. So we have 2 cubed minus, and then there are 4 linear combinations. So it can't be linear combinations of the first 2 rows. Linear combos of row 1/2. Is that cut off? Total. Oh, you can't see the screen, and no one told me. Oh, I'm in shambles. I'm in shambles. All right, read it. Yeah, total minus non-invertible, exactly. So each of these are the reason, like how many non-invertibles there are. And so our total will be 7 times 6 times 4. That many options? Does anyone know what that is? That's going to be, see, this is 24. 24 times 7 be 140 plus 28, 168. That's C. 168, possible? We can cheat and check the answer. I'm pretty sure this is right. I trust me from 2 weeks ago. Let me show you my solution again, because you didn't really get a chance to see what I was writing while I was writing it. Yeah, I think that's pretty straightforward. I hope, anyway. Alrighty. What is number 4? Well, this is a geometry problem. Alright. So we have A, B, C, which is a quadrilateral. AB, this is parallel, right? Parallel to CD. And then we have AB equals 10. BC equals 13. CD equals 14. And AD. Yeah, sure thing. I'm writing it down, but I can show you the question. There you go. And AD equals 15. We want to know area. So I'm going to go ahead and draw this shape. Since we know we have parallel, it's like we can just draw what it looks like. It's just going to be like a trapezoid kind of deal. So let's see. I feel like I'm going to misdraw this. Okay. AB and CD. So CD is longer than AB, so we'll just make that the top. We'll call this A. And call this B. And draw a line there. And this is 10 units. Oops, I don't know what I just did. This is 10 units. And then we have CD, which is longer. Let me make sure I'm drawing it right. So yeah, C needs to be on this side. C, D, like that. And that is 14 units. Then we have BC. This is not to scale at all, by the way. And AD. So basically, it's not like equidistant, if that makes any sense. So we have CD, 14, AD is 15. So that's the longest side. I feel like we should redraw it with that in mind. But anyway, BC is 13. Like that. That's our general shape. We want to know the area. I feel like we can just split this up into a triangle and another thing and then do that. Let me see what they say. Yeah, we can cut this into a parallelogram on purpose, right? So if we draw... I'm trying to think of how we would cut it into parallelogram. So, I mean, we can just like arbitrarily draw this, right? And say that this is parallel to BC, right? And that means this is also 13. And then we've made a triangle with 15 and 13 there. But if that's 13, that means this is 10. And then what's the area for a parallelogram with its sides? I don't know. I feel like that's like an easy formula. We can calculate this area easily. And then we just need to calculate the area of the triangle. Also, that means if that's 10, that means this is 4 units. So we have a triangle there. And we need to calculate, we need to find the height for that triangle. I don't know how we would do that. But let's get the parallelogram area first. I feel like it's really easy. For parallel. I also think there's like a formula, like a general formula for area of... Oh, you need the height of the parallelogram too. Ah. Base times height. That's it. Just base times height. Okay, so the height of the triangle is we're going to be used for the parallelogram. So, parallel, is it agram? Ogram? It is ogram. Ogram equals BH, and triangle is 1/2 base times height. That one I know. Okay. So how would we find the height for this? We're just going to do that with like, I don't know, it's not a right triangle. It makes it not super easy to do, right? I feel like there's... Well, we can split it into 2 right triangles. Oops. Like we can do this little thing here. And then we'd have to find the new base or something like that. If we draw that line, it doesn't mean we split the bottom in half, right? It's not 2 and 2. I feel like we can just use trig here. So we got this right angle. Can do so. Geez, it's been so long since I've done geometry problems. I'm generally pretty good at them though. So can we do like a like the sine of 90 degrees? No, that doesn't work. Can we get this angle somehow at the top? We need an angle somewhere. 90 degrees isn't like helpful. 13 there, 4 at the bottom. I feel like we can... I feel like I'm missing something here. It's like easy. 15 squared minus x squared equals 13 minus y squared. Yeah, that's actually... So you're using like Pythagorean theorem there and relating those two. Oh, that's pretty good. Okay. So we've got... I'm just going to write down what you've said and then look at it. So we got 15 squared minus x squared equals 13 squared minus y squared. And then you said x plus 14 equals y plus 10. And then our x and our y in this case would be, so this is the hypotenuse and 13 minus y squared. Because they have the same height. So you're relating those two triangles there. I got you. Yeah. So x in this case is... Which one's our height? X plus 14 equals y plus 10. So this is y and this is x. And then we'll use that to solve. Okay, so yeah, how do we solve this system then? At least now we have two equations and two variables. Probably with a substitution. So let's solve for y, I guess. So, oops. This will give us that y is equal to x plus 4. So we can plug that in. And we'll get 15 squared minus x squared equals 13 squared minus x plus 4 squared. And this, when you multiply it out, it's going to be x squared plus 8x plus 16. It's equal to 13 squared. Wait, it's negative. Each of those are negative. That is negative. I was hoping the x squareds we cancel. Ah, so close. I almost spared my 16. No, it's fine. It's an I now. Minus. Everything's minus. 15 squared minus x squared. Yeah, the x squareds do cancel there. That doesn't help. Huh. I don't know. Yeah, we need somebody that's not going to cancel our stuff out. Can we just like see a value? Let's like look at this one, right? No, that's not going to help. Oh, maybe. I don't know. And if we do a y substitution, the same thing's going to happen. We could substitute this into this, maybe. Is that gonna help? Let's see what we would get. So we'd have, let's combine some steps here. X squared equals 15 squared minus 13 squared plus y squared. What is this? 13 squared. 15 squared minus 13 squared. Calculator. 15 squared is that. 225 minus, and then it's like 169, I think. Yeah. And then what is that? 225 minus 169. Yeah, your ability to do mental math goes to 0 when you have a calculator in front of you. That's well known. 2 times 28, 56. Yes, you were right. All right, so we have x squared equals 56 plus y squared. That's like a more helpful substitution, I feel like, right? And that won't cancel when we substitute it in. So we'll have x equals the square root of 56 plus y squared. And that means we'll have 50 square root of 56 plus y squared equals... No, it's still going to cancel when we do it. Am I just like tiny braining this? Like I'm just hugely tiny braining this? But this also means we can do a relation for y here, right? We can write a new equation. Y equals, what would it be? Because you move the 13 over, divide by, it would just be the square root of negative 56 plus x squared, right? Yeah, but when we plug that into our other equation, it's still going to cancel, because when we square this, we'll get 2 positive y squareds. So it's not going to like give us anything, as far as I can see. Not saying this approach is wrong, just saying I don't see how to do it. I feel like I'm missing something. Could I just use like a law of cosines or something? What do you need for that? Let me look those up really quickly. Law of cosines. You need... Oh yeah, we could totally do that. It doesn't need to be a right triangle. Yeah, we should be doing law of cosines and stuff. So if we have a triangle, here, law of cosine says we have some triangle like this. Yeah, when in doubt, just look up some stuff, man. It's a study stream, it's chill. So if we have a poorly drawn triangle like this, and we have A, C, B, I'm just drawing it like it's in the picture. They wrote gamma for this. I'm gonna write X. Then we can say that C equals the square root of A squared plus B squared. Oops, got an eraser out. Minus 2AB cosine gamma. But we don't have a gamma, I just realized. Or cosine X. So we have the values. Can we find the angle? I don't know the answer to that. What about law of sines? We're like only one value from that. Oh, you need 2 angles for law of sines. Yeah, so we're further from that. I shouldn't have chosen X here because like we already have an X. This is a horrible. This is just, I ruined my cool shape drawing. This is the Law of cosines. I feel like I'm missing something really basic here. For Are you saying it's? Are you saying this is wrong right here? Like these numbers need to be switched? X plus 10. And then y plus 14? That doesn't really make any sense because 14 is the whole length. I'm gonna like get rid of this for a second because I don't know if this system thing is gonna work out. Just thinking right now. We can write it back out if need be. So we've drawn this triangle to have a base of 4. This one right here. By making this parallelogram. And we could cut off, make like a square out of that. I don't know. So we've got 4 is the whole base. I feel like we can do this. What am I missing, dude? It's like something really easy. I feel like we need to relate the 15 in the 13. Because these two are parallel. And then because by relating them we'll get the length difference there. Like the base difference is what I'm trying to say. And if we get the base, we can get the height. That would be this right angle and that right angle. Are those the same triangle? They can't be because the hypotenuse is different. Huh. So if we call this x and this y, and we cut it up with these dotted lines, then we have x plus y equals 4. Because when we draw those dotted lines there, we will make like the 14 will be a 10 because we made a rectangle there. And then what else can we get from this? I don't know. We don't have really any information about the height. Maybe now's like when we need to write an equation with the 13 and the 15. So we have like what we get. Huh. Maybe now we write an equation with x. What do we know about x? X is less than 4. Yeah, it's all right. It's all right. No worries. I'm trying too. It's a study stream for a reason. Like I said, I kind of want to cheat and use the there's a form. I'm 99% sure there's a formula for quadrilaterals. You can just slap stuff in. I think it's really complicated though. But I feel like I'm missing something really simple. Like I'm annoyed that I don't know the answer to this question. $13. 4. Here, so we know this bottom part's 4, right? Well, I already had that there. I'm gonna see. Huh. Heron's formula. What's that? I'm Googling. I'm gaining information. Heron's formula says what? It's for finding the area of a triangle in terms of lengths of its sides. So we have, I'm just going to write this down. So we have Heron's formula. This isn't really helpful because we want the height. Oh, I guess we could get the height from this though. So if we have sides A, B, C, S is equal to A plus B plus C over 2. And the area is equal to the square root of S times S minus A times S minus B times S minus C. Is that a thing? Is that just a thing? Let's see. So if we did that, right? We have let's do our triangle A here. We have sides. Let me go to the next page. We have sides 15, 13, and 4. So that means our little s is going to be equal to 15 plus 13, which is 28. 28, so it's going to be 16. And then it says that the area is equal to the square root of 16 times 16 minus 15 times 16 minus 13 times 16 minus 4. So this is going to be 12, 3, 1, 16. So this is 36, square root of 36 times 16. That sounds pretty big. I don't know. That doesn't seem right. In fact, I don't think there's... Well, maybe. Okay, well, let's just see. So this is 6, and this is 4, so this is 24. So 1/2 base times height equals 24. Our base is 4, right? So we have this is 4. Yeah, so we have this is 4, so then that means I cancel this as a 2, so that means our height is 12. All right, so if our height is 12 for this triangle, well, we already have the area. The area is 24. And now the height is 12. So that means we just have 12 times 10 for our quadrilateral. So this is triangle area equals 24. And then the parallelogram area is equal to 12 times 10, which is 120. And the area is 144. Now this thing does have the actual answers, so let's check and see. I'll give you the grand reveal because I just don't know what the answer to this is. This is one of the ones I had unprepared if you couldn't tell already. All right, so our answer was 144, which is D. Going into the cheat zone. Keep your eyes only locked on number 4. Actually, I can just only reveal through the ones we've already done. We can check our other answers though. Oh. Yes, it's D. We got it. That works. That's a thing. That's a thing, guys. Look, we've learned Heron's formula. I've learned it live. That's a thing. Oops. Cool. Area is 144. Look at that. Look at us go, chat. Doing stuff on the fly. Look at us go. Who would have thought? Drinking more water. Number 5 is also unprepared for the record, so just get ready for that one. Actually, it's not that hard. I like figured out the trick for number 5. I just didn't actually do it. That one I just like didn't do at all. Okay, so let's see. We have a logic table, logic symbol of the following. So we have if A and B are 0, A hashtag B is 0. If A and B are 1, A hashtag B is 1. So the order doesn't matter. And if A and B are 1 and 1, A hashtag B is 0. So that means we can look at this. Here's the trick, right? We can view this hashtag symbol as like modular, like mod 2, as addition mod 2 specifically. So that means we can like take this table. Wait, is this a not symbol? Somebody who knows more, I think that's a not symbol. Yeah, I'm going to assume it's a not symbol. Let me just look up logical not before I like start doing truth tables and dying. Not symbol. Okay, yeah, it's that. That's what I figured, but you can't ever be too sure. Okay. So that's an and. Okay, so this is interesting. So we got to think about this a little bit if we're going to do it. So not B and A. Yeah. So how would we even like do this? This with that in mind, how do we do that? Not B and A is equal. I feel like this is... Let me check my notes. I think I did like one example of this. That should be all I need to get started. Unless one of you is just like already way ahead of me. Like, dude, come on. You should just be able to fly through this stuff. Honestly, probably. All right. So, okay. Yeah. All right. So let me... That's all I needed was like that little thing. So let me get rid of this. So we have, on the left-hand side, we have not B. We have to be a little creative here, but I don't think it's too difficult. Not B and A. So we can view not B, this, as B plus 1. Right? And then and A, we can do... Is that going to be like times A? I have it written in my notes as like this for this expression. Oh, that means they're the same, right? Not B and A. That means like B plus 1 is equal to A or something, which means B is not A. Anyway, so then let's work on this symbol. We want to know if that's equal to not... Oh dear, this is going to be horrible to break down. Not A. Hashtag B. Hashtag A. Hashtag B. So let's work from like inside our parentheses first. So we have, this is going to be A plus 1 plus B, right? And that's going to be plus A plus B, right? And it's not that. No, it's just not on that first one. Yeah. So... Does that mean we add another plus 1? Yeah. So then we have... I'll just write it like this for sanity's sake. A plus 1 plus B plus 1. Like that. Plus A plus B. right? But the plus ones cancel because we're working mod 2. And then we get a plus b. This is like so weird. Plus a plus b. And that each of these will be 0. Because if they're like if a is 1 and you add it to itself mod addition mod 2, it'll be 0. Keeping in mind that we changed the hashtags to addition mod 2. Like we're defining our plus here to be addition mod 2, but it's still the hashtag. So if you a hashtag itself is going to be 0 no matter what. So the same thing with b. So that means this is equal to 0. And so is that the same thing as this? Because if b, I don't think it is. I don't think that's the same thing. You just check really quickly and make sure. The insecurity mounting. Yeah, no, it's not. It's not that. Well, I mean, it makes sense though because b plus 1. What does the and operator mean? How do we view that? That's important. Here, in our way we're looking at this. B plus 1 and a. Like, how do we view that? That would mean b plus 1. Is that a is that times? Implication. Like trying to turn every one of these statements into an arithmetic problem. What would that mean? Oh wait, they're all the same. All of these, if we can, yeah, that's the only statement we even need to translate because the starter statement of all of these is. What is the answer? Is it even possible to convert that into a logical thing? Is it just E? How do you convert? Yeah, how do you convert not B and A with modular arithmetic mod 2? It doesn't make any sense. I mean, like I can convert this to B plus 1, but and like there's no. Like normally when you're doing a table like this, there's like a true and false, but these are just values. So there's no like true. You multiply them? Okay. Well, even if we multiply them, that doesn't make, well, I mean, like in multiply in what way, right? We don't have like multiplication defined in this system. Like our addition mod 2 is just like a different way to view our hashtag here. But yeah, so like it would be like B plus 1 times A, but like that doesn't make any sense either. Even if that's the way that that's viewed, because like how do you evaluate AB? Because that's not a hashtag B. That's different. Yeah. Is that what this is? If it is, then we can proceed, but I don't think, I'm not sure it's possible to get. Yeah, is 1 supposed to be binary true though? I don't think that's the case. Is that what that means? If we're viewing, yeah, if we view it like a binary where 1 is true and 0 is false, then this is only true. This is only true when B is 0 and A is 1. And that's not always the case given these conditions. So like it's definitely not A. It's not A. Yeah, if we're viewing it like a binary, maybe we can get something out of this. Let's try some other answer choices. So we've got not A plus B, which is just, I'm just like trying to combine steps, but I'm not gonna for the sake of sanity. A plus not B. Wow, that's like a 7. It's a big non-symbol. A plus not B. So this part here will be A plus B plus 1 plus A plus B plus 1, and those explode and everything else explodes, so that whole thing equals 0. It's false. We should view it like a binary. Yeah, I can see that. Okay. So once again, so for this to be, for not B and A, we need a logical right-hand side where B is 0 and A is 1. But how do we do that? How would we show that? You said A hashtag B is AB plus 1. No, I don't think so. How are you viewing multiplication in this case? Yeah. Yeah, I need you to define like what you mean for multiplication. I get the binary being true and false maybe. I think this is kind of sketchy. I'm not sure about this. Wait, yeah, I think the answer is E, because you can't use not and the hashtag to get values for A and B. Like, you can demonstrate that the whole statement is false or whatever. I don't know. I don't think you can get, like, you can't write an equation from these that says B equals 0, A equals 1, which is like what we need for this. Like, can you construct an equation using not A, B, and hashtag? That's basically what E is saying. It's not possible to obtain a logical formula equivalent to not B and A using only not hashtag in parentheses. So can we like make up something, even a simple example, that is logically equivalent to this, which is logically equivalent to not A and B? I don't think we can. I can't even come up with anything. Because how would you encode that? You would, okay, A would have to be true. Yeah, you can't. So like if you were to, yeah, like not B and A is like the way I would write something, like for B equals 0, A equals 1. Or yeah, I don't think. So when A equals 0 and B equals 1, yeah, hashtag B. Hold on, let me read what you said. Is only not true when A and B are both true. No, because A hashtag B is not true when A and B are also not true. That's why we're looking at it as addition mod 2. If you view it as 0 plus 0 is 0, like we can view it as addition mod 2 hashtag. We can just use it interchangeably. It has the exact same properties. So like, yeah, A plus B is not only 0 when they're both 1, it's also 0 when they're both 0. But I don't think you can get a logical formula equivalent, because like I said, I can't come up with an example that will define values for B and A to satisfy the left-hand side of these logical equations. Let me show you the answer choices too, because like you're just hearing me talk. I don't think you can write. Yeah. So you said the same thing. Yeah, I don't think you can write using not and hashtag. I don't think you can write something logically equivalent to the left-hand side. But you weren't like seeing the answer choices. I think the answer is E, but I don't want to cheat until I'm like certain of it. And check. They were both false when it was true. No. Yeah. I don't think we can get. I think the answer is E. Possibly for greater reasons that are beyond my comprehension. I want to lock in E. E. Chat agrees. E. Are we gonna check? All right. Like I said, we won't. We're only checking to 5. We don't want to get any spoilers. Also, we can kind of check the ones we already did, but I don't really feel like going back. I'm right. Come on. Yeah. No, the arithmetic mod 2 thing I figured out earlier. That's not like spoilers. Yeah, I know. I apologize for that. I realized it too late that it was kind of confusing for chat because you couldn't see the answer choices. But yeah, so the answer is E. Yeah, it makes sense though. I mean, I like using only the symbols that they used in the answer choices. I don't even see how you would. Well, you can. This is the answer. I trust University of Chicago math. They seem like pretty smart people. Although a couple times when I've been doing these problems, I'm like, dude, the answer's not there. No, I'm wrong. It is in fact right there. All right, so what's this one? Integer solutions to this thing? To this thing? Did I do this one yet? I feel like I did. I need to find it though. Where are my notes? Where are my notes? That's not it. Do I have it? I definitely have it. Oh, it's right here. No, that's not it. Where are the notes? No! Hold on, how many of these are there? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 10. And I didn't do one. It's definitely here somewhere. I'm tripping. Where are you? Please. My notes. I did this problem. Oh, I don't even need notes for this one. I remember it. You gotta think about it. Okay. Yeah. So let me just get let me write this down in the notepad actually. So we want to know. Here we go. I almost hit delete. So I want to know how many. I'm just gonna write the question down for you. Integer solutions are there to x squared? Yeah, I don't need notes for this thing, man. Equals y cubed. I'm independent, all right? I don't need I don't need any notes. Okay, so this is equivalent to saying when is x squared plus 2 a perfect cube? And our answer choices are A0, it's just 0 through 5. A0, B1, C2, D3, and yeah, no, it's just E5. You can't have footage of me counting to 5. That's the rule. I don't know how many of you were around for my intern days, but that was one of the jokes we had in our videos, is that we can't count to 5, or I can't count to 5, and that is reinforced by the answer choices to this equation. They got to keep me on my toes. I actually think I counted to 5 on one of these previous GRE streams, so I'm just lying. But it's a good thing because they dropped 5, like the government dropped 5 before that. I have footage. 5 is a number. We have this had this ongoing list of like nonsensical math facts that we got from Michael's lectures while we were in number theory, and we would just use them as facts when we couldn't think of answer choices. Anyway, I'm getting off topic, and I'm needing to leave soon now that I'm saying that. Okay, so we know it's going to be 0 or 2 because of this square here. We can always plug in a negative version of whatever. So right away, so if we can prove that there is a solution, we can prove that there's 2, and then we're just done, just by like necessity of the answer choices. So let's look at some squares and cubes, right? So x squared, x cubed. I know the answer. Don't spoil for chat. No. All right. So x 1, 1, 1, 2, 4, I don't know why this is the hard question. 8, 3, 9, 27. And you can see that if we plug in, skipping down, if we plug in 5, we'll get 25. So x equals 5, y equals 3, and x equals -5, y equals -3. Yeah. So we have two answer choices, so the answer is C here. This is a very quick problem. Alrighty, so this one I am not even going to do notes on, not because I shouldn't, not because like it doesn't need any writing, but because the explanation is extremely quick. So we have a politician is heading for a meeting via limo. The thing doesn't matter. Story doesn't matter, but I'll read it anyway. Story time. Running late, the driver wants to take the fastest path. Naturally, the roads are set up as a Cartesian coordinate plane, with a road lying on every point, with one of the coordinates... Wait, what? Did I just misread that? That didn't make sense when I was saying it. The roads are set up as a Cartesian coordinate plane, with a road lying on every point, with one of the coordinates an integer. The driver... Oh, it just means, like, that was phrased dumb. 1 unit away. The driver must go 7 blocks east, 5 blocks north. However, there's an accident 4 blocks east and 3 blocks north. How many different shortest length paths are there from the starting position to the meeting that avoid the accident? So right away, since we're on a like Cartesian coordinate plane with 1 unit roads, so basically you're a bunch of squares and you have to drive around the squares, right? And so he wants to go 7 blocks to the east and 7 blocks east, 5 blocks north. So the fastest way, or like any path is the fastest if it only goes north and east the necessary amount, right? So as long as he moves east 7 times and north 5 times and no other direction any times, that's the fastest path. So there's a lot of fastest paths. So how many different shortest length paths are there from the starting position to the meeting? So in a system like this, I forget what it's called, but there's a formula to determine how many like different options there are, right? So if you want to find how many paths there are from point A to point B, you take the total number of units you need to move, which in this case is 12, because we need to go 7 blocks east and 5 blocks north. And you take 12 choose, we'll just pick north, but like 12 choose 5 and 12 choose 7 are the same. So yeah, it's 12 choose 5. So that's the total number of routes you can have on this coordinate system there. And we want to know how many are blocked by the accident. And I believe that is done with a similar formula. Let me just check to make sure. Yeah, so there are 7 choose 3 by the same logic, right? Because there's 7 total units from your starting position to the accident, and 3 is the blocks north. There are 7 choose 3 paths to the accident, and there are 5 choose 2 paths from the accident. So we'll multiply those two, the paths to the accident and the paths from the accident, and subtract them from the total number of shortest paths to get the answer. So the answer is 12 choose 5 minus 7 choose 3 times 5 choose 2. And that is, I don't know. Let's figure that out. I don't know what that is. So let me write it down before I. 12 choose 5 minus 7 choose 3 times 5 choose 2. And then I'm going to write it out on the iPad so you know what I'm talking about. Okay, so this is, the formula we're using here is, so let me just kind of like draw. So we've got a coordinate system with like a bunch of dots. I'm not going to do all of them. 7 here, 5 up. That's not 5. How did I even think? Yeah, I can't count to 5. Yeah, that's just how it goes. 1, 2, 3, 4. Wow, dude, I'm not even gonna. Horrific counting on my part. That was. Anyway, so this is the total number of units traveled And this is, this is the blocks north. And so we'll like circle this in blue. The blue is the total paths, shortest paths, I should say. Shortest paths. And this is the number of paths to accident. And this is, let's go with red. This is number of paths from accident. And so together, oh, I should have picked colors that like combine, like it would have been cool. Anyway, green together, they are the total. Can you guys read that? Paths lost from accident. Does anybody know? I've actually just been stalling because I don't want to put in the calculator. Does anybody know what that answer is? What's 5 choose? There's no E in paths. Did I write it? Believe me, I know there's no E in paths. I don't know why I wrote that. Sometimes I write with an E at the end when I'm trying to like write with the. I don't know. I just, it's a weird writing habit that I don't know where it comes from. Like I know how paths is spelled, but that's really funny actually. All right, I'm just going to plug this into a calculator real quick. So we've got 12. Hold on, 12. Come on, dude. 12 choose 5. And that's equal to 792. And that's going to be minus, let's see, 7 choose 3. That's 35. And 35 times 5 choose 2. That's probably going to be really small. 5 choose 2, 10. Oops, 10. So 350, that is going to be, what would that be, 442, and that's answer choice A. Okay, cool. There's no E in paths. I can't even believe that I did that. Okay. And I did it live too. Okay. All right, so next we're going to solve the following limit. So we have, let me just write this out in my notes while you guys look at the problem. The limit as n goes to infinity of the product of this right here, 1 plus k over n. For those of you who have been to enough streams to know my handwriting gets worse with each stream, it's beginning. It's beginning. All right, I'll leave that up. I'm going to get my notes up for this problem. Like I said, I did these forever ago. Oh, geez, this looks hard. This looks hard, dude. This looks hard, dude. My notes on this look hard. I think we need to estimate. Well, I don't think we do. I definitely estimated in my thing here. So we want to estimate above and below. Okay. So we're going to estimate from below first. So first let's like manipulate this a little bit. So we have the natural log of L. This is using a trick to turn, yeah, we're going to do that right now. We're going to take the logarithm. But yeah, we're going to use the logarithm trick to turn it into a sum. So we have the limit as n goes to infinity of 1 over k. We're going to pull that out times the, no. We're not pulling that out. I just didn't write the sum. Sum from k from 1 to n. That's just writing this notation. Yes, writing this notation differently. Sorry, brain turned off for a second. Of 1 over k times the natural log of 1 plus k over n. And so our estimate here is going to be that that's approximately equal to the limit as n goes to infinity of sum k from 1 to n. It's beginning. It's beginning. 1 over k times k over n minus k squared over 2n squared. And that, where did this come from? I'm trying to explain it. Oh, so we have that. Where did it come from? Where did it come from? Where did it go? Huh. That's just... Okay, yeah, so we have... Yeah, here, let me write this out for you. So we know that the integral from n equals 1 to infinity of 1 over n squared is equal to pi squared over 6. So this is equal to k times 1 over kn minus 1/2 times 1 over n squared. So that's the like motivation here for this estimation. Okay, so then we have how do we split this up? Looks like if you multiply that 1 over k through, k's cancel. Yeah. Okay, so that's what we're doing here. So then you multiply that through and split up our limits, or not our limits, our sums, and we get the limit as n equals n goes to infinity of the sum from k equals 1 to n of 1 over n minus 1 over 2n squared times, if I can get the pen to work, times the sum from k1 to n of k. Yeah. And so we know that this is 1, and that's going to be minus 1 over 2n squared times n times n times n times n times n plus 1 over 2. And that is going to give us, as n goes to infinity, what are we going to get from that? Well, we get cancellation, right? Oh, the n's just go away, right? Yeah, the n's go away, so the n's... No, because there's still an n in the numerator there, then. Am I missing something here? I think I'm missing something extremely basic. N plus 1. N squared cancels out the n squared, but then we still have an n term. Whatever, 4. Right? Right. Am I missing something here? So that's our... We're about to finish this off. I just want to make sure this step is important, right? Just focus on the highest order terms. So you're saying I just drop that in? Yeah, because in my notes, that's what I do for the record. Because I have from this step, I mean, I can see the n squares cancel. I have this minus 1/4. And that's equal to 3/4, and that's going to be my lower estimate. Can I get someone to confirm that this thing doesn't matter? Oh, because it's smaller, right? Yeah, because it's smaller. We're doing a lower estimate here, so we can just drop off the n. Yeah, that's why we're doing this, right? We're dropping it out of the numerator because we're doing a lower estimate. Am I correct in that? Because we're just estimating. It's not. There's no exactness to this. Yeah. Okay. Cool. Just making sure. Like I said, I did this like 2 weeks ago, so my process is less clear to me, especially because this is a little more involved. Okay. So we have a lower bound for our limit here. And then let's see, what did I have for this? Okay, so our motive for our higher bound, it looks like, is we have the natural log of 1 plus x is equal to the sum as n goes from 0 to infinity of -1 to the n times x to the n plus 1 over n plus 1. And then under that I have integral of 1 over 1 plus x. So we're integrating. Oh, well, no, that's just equal to the integral. Yeah, okay, so that's equal to that integral, which is equal to the sum as, yeah, because you take the integral of 1 over x, you're going to get the natural log of 1 plus x. I said 1 over x. You'll get the natural log of x if you integrate 1 over x, but you get the natural log of 1 plus x if you integrate that. So this is equal to this sum here, -1 to the n, x to the n. So we have 3/4 is less than the natural log of L, which is less than the limit as n goes to infinity of the sum. Let me know if I'm cutting off the screen, by the way, because I'm like focusing on the math right now and not really so much on the stream. 1 over k times k over n minus k squared over 2n squared plus k cubed over 3n cubed. This is like the first 3 terms of that, right? I think so. And so I have this written as 3 over 4 plus 1/3, wow, 1/3 times the limit as n goes to infinity of k times k plus 1. This is like a common result. Times 2k. Am I missing a step here that's important? 2k plus 1. I've like proved this figure here. Over 6n cubed. And then this thing here is equal to the sum as k goes from 1 to n of k squared. Right? So I think I'm missing something here. N goes to infinity. That thing goes to 0. Of the top thing there. I think I'm missing. No, maybe I'm not missing something. I need the evaluations here. So we're taking the first 3 terms, right? So what's the sum of the first 3 terms? Is that what we're taking here? just to get an approximation for an upper bound is what the goal is here. So I'm just going to write out what I have in my notes so you guys are on the same page as me. I have 27 over 36 plus 4 over 36. And my that gives me my upper bound, which is 31 over 36. Is that the first three terms? Can somebody confirm that for that? Of like the k-squared thing? So if we plug in 1, we'll get 1 times... Why is it over 36? Oh, because there's that 1/3 out there. No, that wouldn't do it. Is there another third somewhere? Oh, I have a third out here in my notes right here. Like that. There's only one parenthesis. Okay. So if there is 2/3... No, because that wouldn't do it either. That wouldn't give us a 36. We need a 2 in there somewhere. This is just dropping the n. This is actually not true. This is not equal to k squared. If it's dropping the n, is equal to k squared. So I think it's just that though. So we get k times k plus 1, 2, 2k plus 1, 3. So anyway, our bounding for our limit is the natural log of L is sandwiched between, let me just write this on a new page. We've got 3 over 4 is strictly less than the natural log of L, strictly less than 31 over 36. And what we were supposed to do with that information is figure out what answer is pretty close to that. So let's go to our answer choices here. I'll put them up on the screen as soon as I scroll that far. So we want to know like what pi thing this is an approximation for. So 3 over 4 and 31 over 36. So pi squared over 12 is slightly bigger than 3 over 4. I think that's just it. Because pi over 6 is too small. Pi squared over 6 is too small. Pi cubed over 12 is too big. So the answer is A. It's e to the pi squared over 12. Okay, so that's based on our approximations there. Sorry I wasn't able to nail down the upper limit very well. Okay, I just realized I have to go looking at the time. I'm not going to do number 9 as I said earlier. Number 10 is a pretty straightforward integral. I'm just going to bang these integrals out because they're integrals and I have the notes on them, so it shouldn't be very difficult for me to do these. Okay, so we have, can you guys see the iPad right now? Yeah, you can. Okay. Give me 1 second. Okay. So we're going to set I equal to our integral, which is the integral from 2 to 4. This is using a trick I've already used in these videos before, so I'm not going to go into it too much. Log of 9 minus x. Log 9 minus x. Wow, handwriting just in shambles right now. Log of x plus 3 dx. So we're going to make the following substitution. We're going to let 9 minus u equal x plus 3. And that means that u equals 6 minus x and du equals negative dx. And then for our bounds of integration, we'll have when x equals 2, n equals 4. When x equals 4, n equals 2. And we're going to go ahead and absorb that negative sign to keep our bounds of integration the same. So we can write that as the integral from 2 to 4, getting rid of that negative that comes from this dx to flip these bounds of integration to the way that they're supposed to be. The log, I'm just going to write natural log because it's quicker to write, u plus 3 over the square root of the natural log of u plus 3 and plus the natural log of 9 minus u. That's going to be du. And we're just going to do a trivial change of variables back to x. So we're going to have that this is equal to the integral from 2 to 4 of the natural log of x plus 3 over the natural log of x plus 3 plus the natural log of 9 minus, not u, minus x dx. And so obviously 2I equals I plus I, and we've shown that these two integrals are the same. So let me just do this on the next page. So we have that, yeah. Yeah, I've learned in school that log meant base 10 log, but every mathematician I've ever met has used it to mean natural log, so just keep that in mind when you're looking at stuff. Think about what they actually want from you. And so, yeah, so we have 2I equals I plus I, so our new integral is equal to, from 2 to 4 of just adding these two integrals, right? And they have the same base. So we'll have natural log of, let me zoom in because I cannot read this handwriting, my own handwriting, 9 minus x plus the natural log of x, dear lord, it's so bad, x plus 3 from context, plus 3 over square root of the, isn't that just the denominator? Yeah. Wait, yeah, wait, is it? No, it's close. Is it the same? Oh, it is the same. It's exactly the same. Oh, dear. It's just going to be the, I'm not even going to write it out. It's the same, so this is equal to the integral from 2 to 4 dx, which is 2. Anyway, blasted through the integral. I'm not going to explain. I've cheated. Just know that that works. Yeah, it's the same. It's the same denominator from before, and these are the same. So it's they cancel, and you get dx. Okay, going to the last integral because I need to skedaddle. My apologies for rushing through the last two, but they're honestly not that difficult, so I don't feel that bad. This one is a complex integral, so it actually is slightly more difficult, but I'm just going to blast through it and not elaborate. 0 to infinity of cosine x, or rather it's an integral done with complex methods, x squared plus, is that 4? Yes, 4 quantity squared dx. So that is going to be equal to 1/2 times the integral from 0 to infinity of the real part of e to the ix over the same thing, x squared plus 4 squared dx. And we're going to look at, let me quickly, well, I'll just do it when it makes sense. Look at the limit as r goes to infinity of the integral over cr of e to the iz over z squared plus 4 squared dz. And we have the following contour here. We have r minus r, and we have iz like this with this orientation that I'm like extremely quickly blasting through. And so this is going to be equal to the integral from, okay, yeah, negative infinity to infinity of e to the I x over x squared plus 4 quantity squared dx plus the limit as r goes to infinity of the integral of f of z dz over, if we call this thing like gamma r or something like that, gamma r over that thing, gamma r, and that's going to go to 0. And so that means this is all we're worried about. So that's going to be on the next page. Can you guys see that? Because I am seriously just like speeding through. Oh, you can. Good streamer. Okay. So that is going to be equal to, we're just using residue formula here. It's going to be equal to 2 pi I times the residue of f of z when z equals 2i, because that's our singularity. You plug that into the denominator. And so that is equal to 2 pi I times the limit as z goes to 2i of z minus 2i quantity squared times e to the I z over z minus 2i squared times z plus 2i squared. And this is going to cancel with this. And we're going to get e to the, what are we going to get? No, I don't think that's right. Oh, no, that's not right. That's not right. Try again. Take two. It's going to be 2 pi I, forgot to take a derivative, d over dz of e to the I z over z plus 2i squared, where z is equal to 2i. And that's going to equal the real part of 2 pi I times this huge fraction I'm about to write, I e to the I z times z plus 2i squared minus 2e I z times z plus 2i all over z plus 2i to the fourth, and that's going to be evaluated at z equals 2i. Oh, you're leaving, Luca? Thanks for stopping by. So that's equal to 2 pi I times negative 16 I e to the negative 2 minus 8 I e to the negative 2 all over negative 256. These are going to cancel, and that's going to give us 3 pi over 32e squared. Boom. And that's answer choice C. All right, I have to go. Sorry for rushing through stream here, but I have stuff that is important to do. But thanks for stopping by. Glad I was able to get through all the problems and accurately. I think that's good. Glad I caught the mistake before it cost me more time. Thank you guys for stopping by, and I will see you later.